Your lights dim when the air conditioner kicks on. An extension cord runs warm. The outlet at the far end of the garage reads a little low. Every one of those is the same thing. Voltage drop. And once you see it, it's nothing but Ohm's law. Here's the idea. Every wire has resistance. It's small, but it's real, and it's always there. Push current through that resistance and you get a voltage drop. I times R, and that voltage never reaches your load. The longer the wire or the thinner it is, the more resistance and the more you lose along the way. Three things set how big the drop is. First, length. The farther the run, the more wire there is to drop across. Second, current. The bigger the load you're feeding, the bigger the drop. Third, wire size. Thinner wire, meaning a higher gauge number, has more resistance. Put it together. Here's the formula. Voltage drop equals 2 times L times R times I. L is the one-way length of the run. R is the resistance per foot, which comes straight from the wire gauge. And I is the current your load pulls. Why the times 2? Because the current goes out to the load and comes all the way back. Both conductors drop voltage. Let's do a real one. A 100-foot run of 12 gauge copper feeding 15 amps. 12 gauge is about 1.6 ohms per 1,000 feet, which is 0.0016 ohms per foot. Voltage drop equals 2 times 100 feet times 0.0016 times 15 amps. 2 times 100 is 200 feet of wire, out and back, times 0.0016 is 0.32 ohms, times 15 amps gives 4.8 volts lost in the wire. Your 120 volt load only sees 115.2. 4.8 over 120 is 4%. And the electrical code wants you under 3% on a branch circuit. This run is over the line. So where did those volts go? They turned into heat. Power lost equals I squared times R. 15 squared times 0.32. That's 72 watts. 72 watts cooking inside your wall. That's exactly why a long, thin, overloaded run gets warm to the touch. The fix is simple. Go up a wire size. 10 gauge copper is only 1 ohm per 1,000 feet. Run it again. 2 times 100 times 0.01 times 15, that's 3.0 volts. 2.5% back under the limit. So that's the whole story. Voltage drop is just Ohm's law applied to the wire itself. V equals I times R, doubled for the round trip. The code target is 3% on a branch, 5% on the whole path. The longer the run, the fatter the wire has to be. Next time, we head back to the theory board for the next piece of the puzzle. Grab a pencil, and I'll see you there.